Hello everyone. Today I am going to speak about some of our new results on distinguishing chromatic number of some classes of graphs. Firstly, I would like to define the chromatic number of a finite graph. Secondly, we will define the middle graph introduced by Hamada and Yoshimura in 1976. Thirdly, we will discuss Nihai's results on determining the chromatic number of middle graphs from 1998. Fourthly, we will define the distinguishing chromatic number of a graph, which is a variant of chromatic number introduced by Collins and Trank in 2006. And lastly, we will discuss our main result on determining the distinguishing chromatic number of middle graphs from 2025. So let's start the presentation. A graph consists of a set of vertices and a set of edges, which is a line joining two vertices. In the example, we can see there are four different types of graphs denoted by C6, C4, K33 and K4. Here the vertices are denoted using bullets and the edges are a line joining two bullets. Now a chromatic number of a graph G denoted by chi of G is the least number of colors needed to color the vertices of the graph G so that no two vertices joined by an edge share the same color. In the examples, see the diagram above. The chromatic number of C4, the chromatic number of C6, the chromatic number of K33, these are all 2. And the chromatic number of K4 is 4. Chromatic number has several applications outside graph theory, specifically in the fields of optimization theory, combinatorial optimization, algorithm design, theoretical computer science, etc. Next, we will discuss middle graphs. In this slide, we will focus on some special classes of graphs, namely the middle graph. In 1976, Hamada and Yoshimura introduced the middle graph MG of a graph G. Now, what is a middle graph? So, we are given a graph G. A graph obtained from the graph G by putting a new vertex in the middle of every edge of G and joining the pairs of these new vertices that lie on the adjacent edges of G will give us the middle graph of the graph G. For example, we can see the graph C4, which is a 4-vertex graph, and we just put some new vertices denoted using the blue bullets on every edge of C4, and then we joined these new vertices if their respective edges were adjacent in the graph C4. This is how we construct MC of 4, that is the middle graph of C4. Now, middle graphs has been extensively studied in graph theory. I just listed some of the articles, which is not an exclusive list. Okay. Next, we will discuss Nihai's result concerning the chromatic number of middle graphs. Before that, we need to know some basic definitions from graph theory. Let G be a graph with the vertex set denoted by VG and the edge set denoted by EG. A degree of a vertex denoted by deg of V is the number of edges emerging from the vertex V in the graph G. For example, if you concentrate about the graph C6 and I pick any arbitrary vertex of C6, the degree of the vertex is 2. If I pick the graph K13 and I select the node, the top node, the topmost left node, then we can see that the degree of this vertex is 3, but the degree of the rest of the vertices is 1. So the degree of a vertex is the number of edges emerging from the vertex V in the graph G. Next, delta G denotes the maximum of dig of V, where V belongs to the vertex set. That is the maximum of degrees of all the vertices in the graph G. For example, we can see that delta of K13 is 3. Because K13 is a graph which has one vertex of degree 3 and 3 vertices of degree 1. So the maximum degree of the graph, that is delta of k13, is 3. Moreover, you can see that the delta of C4, delta of C6, both are 2, delta of K4 is 4, delta of K33 equals 3. Next, the main focus is on Nihai's result from 1998. Nihai proved that for any graph, the chromatic number of the middle graph mg is delta g plus 1. So if we apply this result, we can see that the chromatic number of the middle graph of C4 equals 2 plus 1, the chromatic number of the middle graph C6 equals 2 plus 1, and the chromatic number of the middle graph K4 is 4 plus 1. And we can also find the chromatic number of the middle graph of K13, which is 3 plus 1. So this is the result of Nihai from 1998, which determines exactly the chromatic number of a middle graph of a given graph G. Okay. Next, we will discuss the definition of distinguishing chromatic number. But before that, we need to know the concept of a distinguishing vertex coloring. In 1977, Laszlo Babai introduced the concept of distinguishing vertex coloring in the name of asymmetric colorings. So let's understand what is a distinguishing vertex coloring. First, we need to know an automorphism of a graph. An automorphism of a graph is a bijection phi from the vertex set of the graph to the vertex set of the graph, so that if u and v are joined by an edge in the graph G, then phi u and phi v are joined by an edge in the graph G, and vice versa. So you can see from the diagram that u and v are two vertices of the graph G, and we apply the mapping phi, we obtain phi u and phi v. So phi u and phi v are two vertices of the graph G as well. Now phi is an automorphism, that is a bijection, which means that if there exists an edge between uv, then there will be an edge between phi u and phi v. And similarly, if there exists an edge between phi u and phi v, then there exists an edge between u and v. So phi preserves the edge relation. Okay. Now let f from the vertex set Vg to a set of colors 1 to k be a function assigning k colors to the vertices of G. An automorphism phi of G preserves f if fx equals f of phi x. That is, the colors of the vertices x and phi x are the same for every vertex x in the vertex set Vg. Next, f is a distinguishing if only identity automorphism preserves f. So this is how we define the distinguishing vertex coloring. In 2006, Collins and Trank introduced distinguishing chromatic number of a graph. The distinguishing chromatic number of a graph, denoted by chi d of G, is the least integer d such that there is a function f from the vertex set to a set of d colors with the following properties. And this function assigns d colors to the vertices of G with the following properties. No two vertices joined by an edge share the same color, and f is a distinguishing coloring. That is, only automorphism of G that preserves f is the identity. In the example, you can see that the chi d of C4 is 4, chi d of C6 is 4, chi d of K33 is 6, and chi d of K4 is 4. Next, we will discuss the main result. So recall, mg is the middle graph of a graph G. Chi d of mg is the distinguishing chromatic number of the middle graph mg, and delta g is the maximum degree of G. Our main result from 2025 states that the distinguishing chromatic number of the middle graph mg is delta g plus 2 if G belongs to C4, K4, C6, K33. These are 4 special graphs. Otherwise, the distinguishing chromatic number of the middle graph mg is delta g plus 1. So for example, you can see that when I speak about K13, the distinguishing chromatic number of the middle graph of K13 is 4, but distinguishing chromatic number of the middle graph of C4 is 4, and so on. So I collected my results from these publications, and thank you for your attention. Thanks.